Berlin?
No, well, it's part of the Free University.
Okay.
Hi everybody, I am Fichtmueller, and I work at the Botanic Garden and Botanical Museum in Berlin. And I work there as a software developer, which might sound strange, but actually isn't, since we have an entire department called Biodiversity Informatics. So a lot of my colleagues are software developers as well. I started there about half a year ago, and have since been working on a project called Rebind. And I don't really have to tell you what Rebind is about, I can just show you.
This is Bob. Bob is a botanist. He's interested in the flowers of the Madagascar rainforest. Oh, what is this? Looks like Bob has found a specimen of a rare flower. At home, in his office, he enters the collected data in his database. Based on these data, he then writes articles which are published in scientific journals and holds presentations at conferences. But let's skip a few years ahead. This is Alice. She's also a botanist, and she's read one of Bob's articles. Since she's also doing research about the flowers of Madagascar, she's interested in Bob's raw collection data. Luckily, both work in the same city, so she decides to visit Bob. But there's one thing she's not aware of. Bob went into retirement a few months ago. So Bob is not there anymore, and his office is empty. But what is this? In the drawer, there's actually still an old floppy disk with Bob's original data on it. This, however, is still not much help for Alice, since her laptop doesn't have a floppy disk drive anymore. Luckily, the system administrator from the IT department of her institution is able to read the disk and get the data from it. But now Alice has another problem because Bob didn't put much effort in documenting his data structure. So even though Alice now has all the data, she can't use them, as she doesn't know what all the numbers and abbreviations in Bob's table stand for. Too bad for Alice. This data really will help her research. But wait, the story doesn't have to end like this. Let's just go back a few months. Just before Bob went into retirement, he contacted the Rebind project. Rebind is a project from the Botanic Garden and Botanical Museum in Berlin-Dahlem about rescuing threatened biodiversity data. With Bob's help, they were able to read the data and convert them into a commonly used and well-documented XML format. The resulting XML documents are then validated and uploaded to the Rebind servers, where scientists from all over the world can access and search them. Now, Alice can access the data she needs from her own office and in a format she knows. But that's not all. Since Rebind is connected to biodiversity networks like GBIF and BioCase, scientists from all over the world are able to find the documents even though they have never heard of Bob or the Rebind project. Please visit rebind.bgbm.org for further information.
Isn't it great that I get paid to make these kind of movies? Well, actually just this one. Well, what I'm here to tell you about is this, our infrastructure. But usually usually when I tell people about our infrastructure and how we are going to process the data, I'm talking to people like Bob, biologists. Show of hand, who of you is a biologist? Yeah, thought so. Which is why I have to give you a brief introduction to ABCD. ABCD is the data format we are going to use. It stands for Access to Biological Collection Data, and it is, not really surprising, XML format. Just a brief overview on the structure. We have a root element called data sets, and as the name implies, there are one or more sub-elements of type data set. A data set has some kind of general information about it, who's responsible for it, what is it about, and then we have units. Again, as the name implies, units have several sub-elements, each unit. The unit, well, this is where the magic happens. If we look at a big scientific collection, like Natural History Museum, which has a huge collection of insects, each of these individual insects would be a unit. In a zoological garden, each registered animal of the zoo is a unit. And in a herbarium, each dried plant would be a unit. And since there are so many things that can be described using ABCD, there are a lot of optional sub-elements within the unit element. And when I say a lot, I mean really a lot. Just to give you a brief overview, this is the ABCD file for one unit where all the optional elements are in there. So, and just to see, the unit element actually starts. Okay. Here. So that's general contact information. No, sorry. We have a lot of repeating elements, so that's where the actual unit starts. In most cases, they are about 100, 150 lines long. So I've never seen a file this long, except of course this one. Now, when we are talking about biodiversity networks, we usually have institutions, again, museums, zoological gardens, something like that. And each of these institutions has their own database, usually relational database with some kind of SQL-based format, and of course it's well protected. So if a scientific institution wants to share the data, they simply just don't give read access to the database. What is usually done is, there's a software called Biocase Provider software. There are other software packages similar to this one. I'm going to use this one as an example. And in there, an administrator or something has to do a mapping between the individual columns of the database to the specific concepts in the ABCD file. So if we have date column in the database, then the mapping would be, okay, this column belongs to the ISO datetime begin element within ABCD. The Biocase Provider software also acts as a server, so it can be registered with one of the big biodiversity networks. So if some scientist has a specific query, I want to know all the occurrences of a specific plant above a certain altitude, for example. This request is sent to the biodiversity networks, and they spread the request to all of their data providers and send it in a format called Biocase protocol. It's an XML-based protocol which specifies the individual elements within ABCD and formulates these conditions. Since the Biocase Provider software knows the mapping, it is able to transform this request into an SQL query, which is sent into the database, the result is returned, and there the result is converted into ABCD, and sent back to the biodiversity networks using some biocase protocol header wrapped around it, and then either displayed to the user or sent as a data package to the user. These big institutions usually have people responsible for the database who are in charge to keep the software up to date, the hardware working. Our project is focused on small collections, on individual scientists who do not have this kind of big infrastructure. So we are also focused on collections which are closed. So we have one project which is finished, we have a closed data set, and there are not going to be any new elements added, which is why we don't need this entire part. Instead, we focus on the XML part with conversion and have the XML files, store the XML files, and then act just as a regular data provider to these biodiversity networks. But that's not all. The general problem of scientific data being only stored on small computers, being used just as a tool for publications and presentation, but never really being published, is not a problem that is unique to biodiversity. It's a problem that affects almost any research field, which is why our goal is to make our infrastructure in a way that is generic enough so it can be easily adapted to other fields of research. So if we have, I don't know, an archaeologist, they have their own XML-based format, then it is possible to create a service just like ours, based on the same software, using the same principles, with that data format. Keep this in mind when I'm now going to explain a bit our architecture in detail. So we start out by having some kind of data files, structured data files. Could be comma separated values, could be Excel tables, something like this. Usually these files are easily imported into existing relational databases. There are quite a lot of them. Some hopefully will work. With this, we then take the biocase provider software, do the mapping, as explained before, and export the entire data set as a whole into one big XML file, which is most likely invalid. This is due to some limitations of the biocase provider software, but also because the data doesn't necessarily have to be formatted in the way it is expected by the ABCD schema. So we take this example, it would work here, but if the next row in the column somebody entered the date wrong and wrote 10.2.2012, well, this wouldn't be valid in ABCD, since it expects the ISO date formatting. There are a lot of other common problems we can expect, but many of these are specific to the data domain. So, but this is a really easy example. Even though these files might be invalid, they are guaranteed to be well formed, which is why at this point we are already able to load them into eXist. The entire interaction with eXist, not only this one, but everything from now on, will happen via the web interface. So a specialized version of the web interface where we streamline the entire process so that other scientists can use our website. Of course, they might need some expert knowledge from us, some help from us, but the general processing steps are easily step by step and giving the scientists only what they need to have in order to make this process work. So the files are now in eXist. We have two sections, one which is for the work in progress and one section which is then later for the public files. The next step would be to trigger the validation. This is done using a custom xquery function which exports the file again, starts a special application, the correction manager, which is as loosely coupled from Excel as possible. And within this correction manager, we have correction modules, each specialized for a specific purpose. So we would have a module which checks if this date is correctly formatted, and if it is not, well, it tries to parse it and write the correct date in here, or if it cannot be parsed, well, we have other elements. We have another date element, date text, which accepts every kind of text, even if it cannot be parsed. But for the general purpose, we would like to have all in ISO dates to make them better comparable. Once the correction is done, the data is imported again, and it's now hopefully valid. But even if it's not valid, all of the errors should be marked, because every problem that occurs, either potential validation problems or other problems by the individual modules, are recorded. So at this point, we have an entire list of things that either were changed by one of the modules or could cause problems in the validation. And so the next step, we do a manual review, going through these changes, and if the computer, if the module says, yeah, well, I wasn't able to parse this text because it was just complicated for me, I put it in a date text format. But maybe you should try to read it, and if you can read it, well, manually convert it to the ISO date. The review is done using a modified version of the eXist IDE, where all the errors are specially outlined, so one can just click through the individual errors, jump to the specific location, and have a description about the problem. So the file can be easily edited. And this can be done several times, so one could just save, continue the next morning, but eventually we will have a valid file. And individual from the validation, we can also enter additional metadata. Though ABCD has some kind of metadata information, it might not be enough. So we can build, or we are going to build a special form for a specific metadata format, which is then stored in a different specific metadata file. Once we have these two files, we can just click Publish. They are moved to the public section, and from there on, people will be able to query the data set over our website. So the user just enters a keyword, or, and more importantly, connect it to the biocase network, biodiversity networks, using a special module which converts the biocase requests into xquery, and then our files are queried, and the results are then sent back to the data providers, to the biodiversity networks. Yeah. This is basically our structure, and hopefully with architecture like this, we will be able to make scenes like this a thing of the past, and instead enable international collaboration and securing latent data, biodiversity, or others. Are there any questions?
How long did it take to make your amazing animation?
Longer than my boss would have liked to.
That's very nice.
But, it was a bit of work, but it was worth it. Because every time we are presenting our project, we usually start with this little movie, and then people know what it is about. So for those who want to see it again, we have it on our website, and it's on YouTube as well. A lot of small stuff, which you can see it 2 or 3 times and even then discover new stuff.
How many of these files do you currently have, and what's the typical size?
We're currently just starting. Since my colleague, who's a biologist, is contacting different people who might have some old data, and some are really small. I honestly don't know what the biggest file is, the biggest data set is we currently have, but we expect them not to be that large. So I don't know, maybe a few hundred units, something like this.
Yes, about the correction, how do you choose the module that you execute when there's an error? How is it automated? Do you check against a schema?
That depends on your modules. The correction manager is going to be implemented in Java, and the idea is that for every instance of this, so we are one specific instance, we are running this on biodiversity data. There might be other people who are taking the software and run it on some other research field. And a lot of the correction modules are really specific to the schema used. When I'm going to run it, I have to know what are potential problems. So for our case, will be programming a module which looks for ISO dates and then checks if these are correct. But there are also some general modules which work for every kind of XML file where we just do some general validation and then point out, okay, at this element the validation will fail because of this reason. And so the individual people who are running these instances will most likely be required to write their own modules for the specific errors they expect.
As far as I understand, you aggregate data from different sources, so it could be the case that one and the same flower comes from two different sources.
Yes.
Do you make recognition that they are the same object? Or?
That's part of the schema to check. So there are also a field for scientific name in here. So biologists have scientific names for certain plants, and hopefully they are spelled correctly and written in the same way. And so the idea is, if somebody queries us, for example, via the biodiversity web networks or via the website, just having the website form and then say, yeah, give me all the records you have about this specific plant, and enters the scientific name. And we have the same plant in different data sets, well then segments of both data sets will be returned. That's of course a really key part also in the general concept of biodiversity networks, to get the data from different sources.
Another question. Your correction manager does XML to XML conversion. So why do you shell it out to Java and back into it?
We could be able to do all of this in Xcode. Yeah. The reason is because we are going to, as I explained, at some point other people will have to work with it and implement their own modules. And it's just, yeah, from my perception, there are a lot more people out there who are able to implement a Java interface for a specific class and then just drop the jar file in a specific folder instead of people who are able to write Xcode code.
Are there any specific things you miss for within eXist? You need certain features you consistently use?
I prepared a small list of things I noticed about eXist, but it's for the open session later on. Okay. Really missing. So far, we are quite happy with what we got, especially using all the interactions with a modified version of the admin interface. Can't think of any right now. On my list there are a few which are more general, more kind of usability level, but not specific features.
Okay.
I have to show it because, well, we get public funding, so we're supposed to mention it.
Okay.